Hi, in this tutorial we are going to solve a question related to mechanism. The question asks, provide a mechanism for the reaction given below using curved arrows. Let's look at the reaction. We have here an alkene, cyclohexene, and here we have a peroxyacid, which is metachloroperoxybenzoic acid. Let's write the names. It's going to be an exercise also. So this is an alkene. The first one is an alkene, which is cyclohexene, and the second one is a peroxyacid. It is metachloroperoxybenzoic acid. And peroxyacids generally they have this generic formula RCO3H. So they are different from carboxylic acids, because carboxylic acids they have two oxygen here. So as you remember, when we have an alkene, when we have a peroxy acid, we are going to form an epoxide. Okay, let's try to draw arrows corresponding to the reaction mechanism, and for that reason we can use red markers. Okay, let's start here. First of all, let's look at what kind of new bonds we have and what kind of bonds are broken during the reaction. Basically, the alkene functionality we don't have anymore here. We have here two new carbon-oxygen bonds, and if you look at here, this bond is broken. Oxygen-hydrogen bond is broken. A new bond is formed between here hydrogen and oxygen. So let's start. So basically we have to form a bond between this oxygen and one of the carbons. So we have to start with a lone pair, a curved arrow, a polar mechanism. So this corresponds to this sigma bond. Then we have to generate a second sigma bond between this carbon and this oxygen. So for that reason we have to use here the pi electrons, pi bonds. So let's move this one over here. So basically here we accounted for two new sigma bonds. Then let's continue. The bond between this oxygen and that oxygen should be broken, so we have to show it with curved arrow. So what is happening? Instead we should have here a double bond, carbon-oxygen double bond. So basically the electrons should move here to make this pi bond. Let's make it better. Okay, then what do we see? We don't have here anymore double bond, carbon-oxygen double bond, and what we have here oxygen and hydrogen sigma bond. So basically we have to use this pi electrons to make bonding between this oxygen and this hydrogen. Sometimes people show with two steps, like they use these pi electrons to make lone pairs, then lone pair electrons make bonding with this hydrogen. Okay, but generally people like you need to show in a single step, concerted step. Then when we look at here, the hydrogen and oxygen bond should be broken, so these electrons should stay with oxygen as a lone pair. So basically we used 1, 2, 3, 4 and 5 curved arrows to show the transition from reactants to the products for this particular reaction. And don't forget, when you have an alkene and a peroxy acid, we form epoxides and also carboxylic acid. So what's the name of this molecule? Basically this is 1,2-epoxy cyclohexane, and this is metachloroperoxybenzoic benzoic acid. Thank you so much for watching this video.